Ever wonder how companies like Netflix or Spotify can possibly handle the insane amount of data they crunch every single second? Well, the answer lies in a story about two revolutionary technologies that completely changed the game. So today, let's dive into the story of Hadoop and Spark.
To really get why they were so important, we have to go back to the early 2000s. And we have to ask a really basic question. What happened that was so big that the old way of doing things just completely broke? And the answer, in 2 words, is the data deluge. The internet wasn't just growing, it was exploding. And the amount of sheer information being created, well, it was something the world had never, ever seen before. And this created a massive problem. You see, the issue was pretty simple at its heart. A single computer, even the most powerful, beefiest machine you could buy, just couldn't keep up anymore. It couldn't store all the data, let alone make any sense of it. So the solution seemed obvious: spread the data across a whole bunch of computers. But that just created a brand new headache. How do you get them all to work together? And this is where the first hero of our story steps into the ring. A piece of technology designed specifically to tame this new, wild beast of big data, Apache Hadoop. So what exactly is Hadoop? Well, at its core, it's a framework for doing 2 things really well. First, it stores giant data sets across clusters of normal computers. It uses something called the Hadoop Distributed File System, or HDFS. Just think of it as a clever trick that makes 100 computers act like one single, enormous hard drive. And second, it processes all that data using a powerful model called MapReduce. And the origin story is pretty cool. It all started at Google, where they had the basically impossible job of indexing the entire internet. To solve it, their engineers wrote these brilliant papers on their internal systems, the Google File System and MapReduce. They basically published the blueprints. And in 2007, an engineer over at Yahoo read those papers and built an open-source version for the whole world to use. And that became Hadoop. Okay, so let's zoom in on MapReduce, because this is really the engine room of Hadoop. The whole idea is based on a classic strategy: divide and conquer. You don't try to solve a massive problem all at once. You chop it up into smaller, manageable pieces, have a bunch of computers work on those pieces at the same time, and then you cleverly combine the results.
This whole divide and conquer thing happens in 3 main stages. Imagine you need to count every single word in a huge library. First is the map stage. You'd give one book to each of your friends, your worker nodes, and just have them count the words in their book. Then comes the shuffle stage. This is where the system automatically collects all those individual counts and groups them together by word. Finally, there's the reduce stage. Now you ask your friends to sum up the counts for each specific word to get the grand total.
And you can see that flow perfectly right here. Raw data comes in, it gets mapped out to different workers, it gets shuffled and sorted into these neat piles in the middle, and then it's reduced down to a single, clean answer. Simple, powerful, and built for absolutely insane scale.
Now, Hadoop was an absolute game changer, no question. It was reliable, it could scale, and it can handle data sets bigger than anyone had ever dreamed of. But it had an Achilles heel, a fatal flaw that became a huge problem as data analysis got more demanding. That flaw? It wasn't always very fast.
And that brings us to the next big turning point. You see, Hadoop was incredibly thorough and careful. But in the world of data, sometimes you need answers right now. So what happens when being thorough just isn't fast enough?
Hadoop's design created these huge bottlenecks in a couple of key areas. First, for anything iterative, think training a machine learning model where you have to chew on the same data over and over again. And second, for interactive queries, where a data scientist just wants to explore and play with the data in real time. For that kind of spontaneous work, Hadoop was just way too slow.
And just how slow are we talking? Well, this chart tells the entire story. See those blue bars shooting way up? That's Hadoop. And that flat little red line hugging the bottom? Yeah, that's Spark. The difference isn't just big, it's staggering. We're talking orders of magnitude faster. It completely changed what was possible.
So what was the secret? It's all about where the work happens. Hadoop's MapReduce was built to be super safe. After every single operation, it would read data from the slow hard disk, do its work, and write the result right back to the disk. Spark had a totally different idea. Keep the data in the computer's lightning-fast memory, in RAM, while you're working on it. It avoids all that slow back and forth with the disk.
And that single, key innovation is what made Apache Spark the clear successor.
It was the next generation of big data processing, built from the ground up for the speed that modern data science and machine learning were demanding.
And just like Hadoop, Spark has this fantastic underdog origin story. It didn't come from a huge corporation. It came from a research group at UC Berkeley. They took their idea to all the big tech companies, but as one of the creators said, none of them picked it up. So they did the next best thing. They open-sourced it, gave it to the world for free, and it just took off like a rocket.
The magic behind Spark is this concept called a resilient distributed data set. Yeah, it's a mouthful, so everyone just calls it an RDD. Just think of it as a special collection of data that's spread across many machines. It's resilient, which is key. It means if one machine fails, the whole system doesn't crash. It just keeps on going.
But wait, how is it fault-tolerant if it's not constantly writing to disk like Hadoop? This is where the recipe analogy comes in, and it's absolutely brilliant. See, instead of saving the finished cake after every step, Spark just saves the recipe. It keeps a log of all the instructions, the lineage, it used to get to the final result. So if a piece of data gets lost, Spark doesn't have to start over. It just looks at its recipe and quickly recreates the missing piece. It's an incredibly elegant way to get both speed and reliability.
So look, this isn't just a tech history lesson. This fundamental shift from Hadoop's batch processing to Spark's in-memory speed completely changed what was possible, and you see its impact literally everywhere today.
So who's using Spark? The list is a who's who of tech and industry. When Netflix recommends a movie, that's Spark. When Goldman Sachs analyzes financial data, that's Spark. And that personalized playlist Spotify makes for you? Yep, you guessed it. From e-commerce to scientific research, Spark is the hidden engine powering our modern world.
So the pattern is pretty clear, right? The massive data challenges of the 2000s forced the creation of Hadoop and Spark, which leaves us with one final, fascinating question to think about. What are the defining data challenges of our time, and what revolutionary new technologies are being invented right now to solve them?